I'm going to talk about JChem and the chemical search database search technologies. Let's get started what products I'm going to speak about a little bit. So the products in this question, the JChem Base, I think all of you know JChem Base. It started approximately 17 years ago. So it's really a major product. We worked a lot to make it very, very good. And this is a Java-based library. So the JChem Base is actually, you can find it in nearly every ChemAxon product where you can find search. And it's not just for us. This search technology can be built, and they are built in usually in our VAR partners. The next one, the two cartridges. The JChem Oracle cartridge, which is also a major product. It's already, I think it's 50 years old. And the little brother, the JChem PostgreSQL Cartridge, who is just 2 years old. So he's not as major as the Oracle one. The question which usually comes to a user that, okay, I can see that you have JChem Base, you have JChem cartridges, so which should I choose and why? So as I told you, JChem Base is a Java-based technology. So if you want to use JChem Base and search using databases like Oracle or Postgres or MySQL or whatever relation databases, so it can connect to many, many databases, you need to write code. And for the JChem Oracle cartridge, or the Oracle cartridge and the Postgres cartridge, you are on the SQL level, and the chemical intelligence actually integrated into the relational database with the SQL expressions, and you have functions or you have operators which are providing the search capabilities. So what is the advantage of one or the other? I would suggest something like this. If you have a chemical structure column or a bunch of chemical structure in one table, but you have additional information in your database, like a pKa value, mole weight, or whatever chemical information you like to search with, then probably the cartridge is a better choice. Why? If you are just search for chemical structure and no other non-chemical filter that you are working with, then it doesn't matter whether you use JChem Base or the cartridge, they are approximately on the same speed. But if you go into the details and you want to combine the chemical search, the substructure similarity search, with non-chemical filters like mole weight or like joining with another table, then you can take the advantage of the query planner, which is provided by the Oracle of the Postgres, and that's the query planner is providing you the capability to run the search, the whole expression, the chemical and the non-chemical one, in the best execution plan, in the fastest way. And that is provided by, actually it's not ChemAxon is doing that, we're just providing the support for Oracle and Postgres, but the Postgres and the Oracle Query Planner is using some statistics and additional information to do the fastest execution. And finally, the web services is just another layer. When you want to use the RESTful web services, then we provide the searching capabilities through the RESTful calls. I may also mention that all of these products can expose some part of the other ChemAxon products, like, for example, calculating some values or some properties for your structures. You can do it all of these products if you have the proper license from ChemAxon. OK, let's go back to the search. OK, there are typically two scenarios in searching. One is, or let me call it, it's an interactive search. The interactive search when you or your colleagues sitting to the computer and like you are Googling something, you are Googling the database. So you are drawing the structure, you are checking the result, and you are modifying the query structure to get better results. And this is an iterative process while you get the number of structures you are interested in. The other situation when you are using a workflow tool. In the case of a workflow tool, then the search is just a little tiny bit in the nodes, that you have a database, you have a searching part where you, for example, looking for a specific project, or you can looking for specific moieties in the structures, and then you go on the next node. Next node does some calculation on this node, on these structures, and then you probably have a huge number of results, and then you cluster it, and what actually the end part, what you finish up with is a plot where you modify some parameters, and then you finally get the results, like an end of a clustering or something. But here, the difference is that here the search is just a little bit part, and you don't refine continuously the query structures, but you refine something just after it, in the rule engine, at the end, and for example, the level of the clusterings and things like that. So I hope you get the difference between the two one, and we will focusing to improve the interactive search. And for this reason, in the Postgres cartridge, we introduced the relevance search. So in a typical search case, when you are searching with hydroxycoumarine, for example, that structure, then the hits are just returning back in any order. The relational database doesn't provide any ordering by default. Of course, you can put the order by text in your SQL query, and then it will be ordered by a column or something like that, but not in any chemical manner. And what we implemented is relevance, which means that if you provide the query, then the first hits, like in the Google, the first hits will be the most similar one to the query structure. I think that's why you like the Google, because when you are searching with the Google, then the first hit is really close to what you are looking for. And if you are not there yet, you didn't find what you wanted, then you modify the query a little bit, and the search hits again is updated accordingly. So that's what we wanted to achieve with the relevance sorting of the hits. I should also mention that the relevance sorting doesn't change the number of hits or the results. So even these structures, which are here, are also appears in these results, but just probably on the bottom side, because these are much more complicated structures. So the number of hits are exactly the same. If you are following this idea, then you can go to the hits as you draw. So you draw the structure, and you get quick hits from the database. Let's say this is 5 hits based on the query structure. And this is nice, because when you are drawing, you get ideas from the database. And even, hopes you arrive this point, remember this point, there are no quick hits. You can blame the database, or you can blame the engine that, oh, the engine should be bad because it didn't find any hits. But it's not. It's actually the situation that it didn't have any hits in the database. So it's very important. It's not just when you get the hits, what you get, and you get another ideas, but even very important, if you don't get hits, that can open new ideas that, oops, okay, and the next one, I don't have this structure in the database. Do I need to get this structure in the database? Does it open new possibilities for me? So it's not only the hits can you provide answers, but also the negative answer. Okay, what you need to able to do this hits as you draw feature. You need to have speed, quick answers. And here I will show you a comparison with the Postgres cartridge comparison with Oracle cartridge. The Oracle cartridge is already, as I told you, it's already in the market. It's a well-known, let's say, industry standard searching engine. And that's why I'm comparing with our tools. So the blue one is the JPC, is the Postgres cartridge, and it's nearly invisible. And what you see here in these graphs are, the first one is the duplicate search. The duplicate search is also called exact search when you're searching exactly the same structure. And the second, third, and the fourth one is similarity search. The first one of the number of hits if you get similarity over 80%. The next one is the similarity of the structures of the top 100. And the last one is the all hits in the similarity. As you can see, the Oracle cartridge is, yeah, it's not very nice, but the Postgres cartridge is working very, very, very nicely in this question. Yes, I didn't show in this figure that what happens if you have to pull back all the database, because this is not a typical situation. So when you put the similarity threshold to 1%, so over 1, then you get back the whole database, because that's not a typical. So that's why I've chosen 80%. When you don't, you actually won't get back the whole database. Oh, I should also mention the size of the database. So this is 8 million structure currently I'm talking about. And the time is in milliseconds. So this is the similarity search, and Gabor will talk about the MedFast similarity search, but yeah, this is already very close to really, really fast one. What we also implemented is this very similar thing on substructure search. So the left figure is just the substructure search. The right one is substructure search combined with molecular weight, with non-chemical search. So it's a combination of chemical and non-chemical search. Why I'm focusing on this combination of search? Because that's very typical in a cartridge use case, that you not just chemically searching one, but you have an additional filter, for example, on price, or on some values, molecular weights, or whatever. For example, rule of 5, whether it satisfies the rule of 5 or not. Again, back to the number. Oh, sorry, maybe I need to mention that what are the columns. So we have different query sets. I don't want to go into the details of the query sets, but the difference between the query sets, that how frequent the hits are, that how many % of the database are returned. And the first one is when you have very frequent queries, but you are just need the first 500 hits from the frequent, which means that you don't want to get, let's say, 100,000 hits back, because I'm focusing, just remember, I'm focusing on the first place of when I continuously checking my result. I want to see the first 100 hits, or probably not the first 100, because I cannot digest 100 hits, but let's say first 20, but I can paginate for the laters. But I don't want to get back 1 million structure, because as a person, I never ever want to digest 1 million structure. And oh yes, the other one is again similar, 500 hits, and it's a combined search. And these figures are nice. Yeah, you can see the red is long time, the green is very tiny, but then you will typically ask, okay, nice, but okay, how fast is it in reality? So if you take a joint search, a combined search with 8 million structure that don't blink, because if you blink, that takes 300 milliseconds, and your hits will back in 265 for some structures. So don't blink, just stare. This guy sometimes blinks, so he cheats. The other, you see? The other one, the human reaction time, it's 100 milliseconds. So you can create a new game from it, but I don't think ChemAxon will enter into the game market with Postgres cartridge, at least not. So you can try to cancel the hit when you have, let's say, a substructure search and the first 500 structure. Try to cancel it. It comes back in, let's say, 50 milliseconds, and the human reaction time is 100 milliseconds. So it's all nice, but we have one little problem to solve. And this little problem is no more excuse for the coffee break. So if you go for coffee break, you shouldn't say that, my searching is, no, you should say that I go for coffee break to discuss this problem with my friend and not because of the search. Thank you very much.
So you threw out two terms there, similarity and relevance. I'm wondering if there's a distinction between similarity search and relevancy search.
Yes. So in a similarity search, you always want to get back the results based on the similarity. This is very... But in a substructure search, it's the typical answer is that I have these hits, and what is the relevance? It's based on the similarity on the query structure and the target structures. So the relevance actually means that we return the hits based on the similarity to the query structure.
So in your charts, it was red was Oracle cartridge,
Yeah.
And they were much larger than the new kit in the block, the Postgres. Why do you think that is?
Oh, of course I know, because we are using different technologies. So on the back end, we on the Oracle cartridge is relying on the JChem Base technology built, as I told you, 15 or 16 years ago. And the Oracle cartridge is also 15 years old. And we wanted to go and change a little bit of the technology. And what we did is refactored some part of the JChem Base core search technology to models. And we reused that models, but in a different manner. And we used other tricks in the Postgres cartridge. I don't want to go into the technical details, but that's with the new backend that we are using now, we are able to use these tricks. So if you were asked me to, and will we implement it in the JChem Oracle cartridge? Not that. Maybe a new one, but not in the current one, because it's not possible to do that. Mm-hmm. We had to do that step to change the backend technology there.
Any plan to do the same thing for Oracle cartridge?
Yeah, this is a good question. If there is an interest for them, then we will consider it. But yeah, let's discuss it. I mean, saying something like that, it would be nice to have. Yeah, I would be glad to have an ice cream, so.